In this video lecture, we are going to see one topic, linear classification models from the third unit. The third unit is supervised learning for the subject artificial intelligence and machine learning. Myself, Hasina Bibi, Assistant Professor of CSE Department, Rohini College of Engineering and Technology. Objectives are to understand the linear classification models and to analyze logistic regression. A classification algorithm is otherwise called as classifier that makes its classification based on a linear predictor function combining a set of weights with the feature vector. So the classification algorithm uses this linear classifier model to perform the classification. So it uses the combination of linear characteristics. Linear classifiers can represent a lot of things, but they can't represent everything. So the classic example of what they can't represent is the XOR function. Linear discriminant analysis, it is otherwise called as LDA. It is most commonly used dimensionality reduction technique in supervised learning. In supervised learning, linear regression or linear classification models are used as the pre-processing step for pattern classification and machine learning applications. It is actually LDA is a supervised learning algorithm. It requires a labeled training set of data points in order to learn the linear discriminant function. The main purpose of LDA is to find the line or plane that will best separate the data points belonging to different classes. And it is most widely used machine learning algorithm due to its accuracy and flexibility. So LDA can be used for variety of tasks such as classification, dimensionality reduction and feature selection. So this is the diagram. Before applying LDA, the data points are there, different types of data points are there. Actually in this example, two types of data objects are there. So after applying LDA, the purpose of LDA is the LDA will find out one line, or it is called as, this line is called as plane, which will separate different data objects. So one kind of data objects are accumulated into one side of the plane, another kind of data objects are accumulated into another side of the plane. So in this way LDA is used for classification. So actually the LDA algorithm works based upon the following step. The first step is to calculate the means and standard deviation of each feature within class scatter matrix, and between class scatter matrix will be calculated. These matrices are used to calculate the eigenvectors and eigenvalues. LDA chooses the k eigenvectors with the largest eigenvalues to form the transformation matrix, and finally this transformation matrix will be used to transform the data into the new space with k dimensions. So once the transformation matrix transforms the data into new space with k dimensions, LDA can then be used for classification or dimensionality reduction. So the benefits of LDA are, it is used for classification problems. It is a powerful tool for dimensionality reduction. Then logistic regression. So it is similar to the linear regression, but here logarithmic values will be used for the calculation. Then regression component. These are the methods used to quantify the association between an outcome and predictor variables. It could be used to build predictive models as a function of predictors. So in logistic regression, the formula will be there. That is, if you want to calculate the probability of y, x is the x may be the response variable. In logistic regression, the response variable is an indicator of some characteristic, that is 0 or 1 variable. So here the sequence of x values along with the beta, so linear regression coefficient is called beta is nothing but the regression coefficient values are used, and their combinations are used to find out the the value of y. So here the logarithmic value will be applied to calculate the exact value of y in logistic regression. So here when we consider the graph, linear regression will have the straight line and the logistic regression will have the curved line. Again, we can see the equations, the difference between the linear regression and the logistic regression. In linear regression, simply we will calculate the probability value, but in logistic regression, we will calculate the logarithmic value for the particular probability. The linear model assumes that the probability is a linear function of the regressors, while the logistic model assumes that the natural log of the odds of the p is a linear function of the regressors. Thank you.